Paul, I love the questions. Great question. I think that's a great question. I think that's a great question. It's a great question. It is a very important question. Two very good and interrelated questions. It's a difficult question to answer, but it's a good couple of questions. Paul, I love the questions.
Yeah, thanks. That's a great question. It's a great question. That's a good question. Great question. I think it's a great question.
Excellent question. Excellent question again. Certainly another excellent question.
Oh, that's a great question. That's a great question. Yeah, so that's a great question. It's a great question.
Well, great question. I mean, I think these were great questions.
Oh, that's a really interesting question. Such a good question, Paul. Excellent question. What an interesting question. It's an interesting question.
This is a difficult but very important question.
I think that's a very good question.
Well, that's a very interesting question, Paul. It is an open question.
It's a difficult question.
To be honest, that's actually a bit of a difficult question.
Yeah, no, I mean, it's a good question.
Again, it's a good question.
I think we can start the conversation from a more positive perspective, which is acknowledging the progress that has been made globally in the fight against malaria, but still putting it in context of what the current challenges are.
Sure, yeah. So starting with context, I think that's a great question. Well, the story of malaria it's a big story. It is a big story. Throughout history, malaria has been responsible for an incredible level of death of the human population. And over the last 3-4 decades, as progress has been made against malaria, and in many parts of the world, malaria has been eliminated, eradicated. But unfortunately, in part due to climate change, rapid urbanization, and the overuse of traditional chemical pesticides and other measures, we're actually starting to backtrack or backslide in the fight against malaria. And then that's not good news. In fact, I am very troubled, as are many in the public health community, that in essence, we're losing ground. And I think as we talk about the Djibouti project we're operating, we're seeing rapid spread of an invasive malaria vector that is benefiting from climate change and rapid urbanization across the African continent. It's a very important time for us to double down, to advance new innovations very quickly and at scale, so we can start taking back the ground in this fight.
That is absolutely a good introduction. So, who started this discussion? Did you approach the Djibouti government or did they approach you? So what was the meeting point between your organization and the government of Djibouti?
Yeah, I believe it was late 2018, early 2019, when the government of Djibouti came to us and asked if we would be interested in developing an Oxitec friendly mosquito to combat this invasive mosquito called Anopheles stephensi. And we were thrilled to receive the request. You know, there's nothing better than a country, a government coming to us to ask if we will help solve a problem with them. And I think there are 3 elements that I am excited about in relation to the partnership. One is the government is leading the way. The Djiboutian government and our key stakeholders there are just outstanding leaders. They're outstanding public servants, and they had a bold vision for using a groundbreaking technology that we can develop to solve a major problem that they were facing. And they are facing a significant challenge. And that's really part 2 of why this is an exciting project. In Djibouti, malaria has roared back after they got to near elimination in 2012. And it's a very, very difficult story and condition they're experiencing. And that urgency is there. The government is urgently pursuing solutions with us. So government's in the lead. They're moving very quickly and in a concerted way. And then number 3 is we're building a technology with input from experts around the world, but we're now beginning to project out into other parts of Africa, thinking through with regulators, with political leaders, with stakeholders and regional organizations. So as we complete the technology in Djibouti, we then are able and capable of moving it into other areas that are also desperately in need for a solution to this particular malaria vectors. Those are kind of the ingredients of why this project is so exciting. And it's also the reason why the project has been a success to date.
Let's talk about the uniqueness of the malaria situation in Djibouti that makes your solution the best way to address this problem.
Good. Great question. So the unique nature of the challenge in Djibouti is due to the fact that the malaria being spread in Djibouti is being spread by this mosquito that lives in urban areas. And if you zoom out and look at where most malaria transmission is on the African continent, in Southeast Asia, in parts of Latin America, it's normally in rural areas. Rural areas, bodies of water, and an absence of services make the malaria to date has been a rural story. And so now, as a new malaria vector enters these cities, it wants to live in and around humans in very densely populated communities. It thrives off of urban environments, and that poses a problem. One is we don't have a lot of tools in the toolbox to fight malaria vectors in cities. This is a daytime biter, so bed nets are not going to have a major role in protecting the population. And they like to be outside and bite outside, which means indoor residual spraying, which is very common in rural parts of Africa. That also is not going to be helpful. Finally, as if that doesn't make it complicated enough, the chemical pesticides that governments have to fight mosquitoes in urban environments are basically useless against this particular mosquito because, at least in the Djiboutian context, the mosquito, this species, has developed resistance to all major categories of the common pesticides used in that part of the world. So, with all of that being the backdrop, we are perfectly suited. Our technology is perfectly suited to be deployed in city environments, efficiently released. Our friendly mosquitoes are males, they do not bite. So as we release them into communities, they will seek out and mate with wild type females, and all female progeny die. And because our mosquitoes behave like wild type male mosquitoes, it's a very targeted, very surgical way to control this vector without killing any other beneficial species, without creating harmful side effects. And ultimately, once we have controlled the mosquito, our technology is not permanent in the environment. So it is a completely sustainable solution. So you put all that stuff together, and we are we're working day and night to complete this technology, to get it out there.
Yes, let's talk about the technology. And so if you can take me through the development process of this technology, the ideation, it's at its current stage of implementation, the technology, not the rollout.
Oxitec technology of the type that we're developing for this particular mosquito uses a few helpful adaptations to a mosquito's DNA, such that we can rear up mosquitoes. They lay eggs, and we can take those eggs and place them into very simple form factors, typically as eggs. And when we move those eggs to the field for deployment, it's a just add water application. So small boxes or kind of cases that field operators can deploy very, very easily. And when you add water to those solutions, or to those form factors, only male mosquitoes survive and come out. And those are our friendly male mosquitoes, and they go out and do their work. So the helpful adaptations in the genetics has been proven now. I think we're 22 years in development of these types of technologies. We've deployed them around the world. We have an outstanding scientific track record. And for your listeners or viewers, we have over 100 peer-reviewed publications, so scientific juried papers on our website, which can easily be found. Once we create the genetic kind of adaptations for a particular product we're developing, we then work on all of the product systems beyond the mosquito. So everything around the mosquito that has to be solved for so that it can be manufactured at scale and cost effectively, so that it can be deployed efficiently by kind of folks that don't need to be experts in mosquito control. And ultimately, when we move it to the field for the first time, we work with governments to do field trials or field pilots. And those field pilots are initially designed to demonstrate to government regulators that the technology is safe, effective, and non-permanent. And that's the stage we are entering now in Djibouti. The mosquito is done. The rearing systems have been de-risked, and now we are in the field just as of a few weeks ago, carrying out a very robust scientific endeavor to do those things I mentioned with regulators. All the while, it's being done in partnership with government and with communities.
Let's talk about the phases and the experiences that you can share from the release of these mosquitoes so far.
Yes, so you are right. This is the second release, but I will say this last couple of weeks was the kickoff of the real scientific effort. Earlier this year, we did a very small release to celebrate the project and the kickoff of the project. And then again, a couple of weeks ago, we got into the real work. So that real work is going to take a couple of years. So we're doing field pilots right now. And we do gradually larger field pilots in different communities under different scientific kind of parameters to generate the full body of evidence about the potential utility of this solution. And Oxitec is very, very scientifically robust. We are very difficult graders of ourselves, and we work very, very hard to demonstrate the effectiveness of this solution and to continually improve it. But given that it's safe, our gene system, these product types are being commercialized in Brazil, for example, at scale. It's really about execution in Djibouti in the specific context of a very hot, dry, and yet coastal city where communities are suffering from this malaria vector. It's a chance for us to adapt the product system in a way that is optimized for releases in that part of the world. Once we do all that, and maybe at risk of going on too long, once we finish those field pilots, we will be able to show the world that A, we can suppress Anopheles stephensi very effectively. B, that the technology is completely safe. And C, we can scale this technology and it's ready to go. So again, we have a couple of years. We don't have any data yet because we just started 2 weeks ago, but all of the conditions, all of the ingredients for success have been established and added to the effort.
Why focusing on this particular type of mosquito? Can this similar system work for the Anopheles mosquito that transmits Plasmodium falciparum? So why the specific species of mosquito, and what is the application for other types of mosquitoes?
Yeah. So again, great question. When the Djiboutian government came to us to build this solution, it was because this mosquito is new in the African continent. Djibouti really was one of the first places that started suffering from this particular mosquito. And it is one species that is responsible for this incredibly rapid transmission of malaria. So for us, it's a perfect target because it is one mosquito, and if we knock that mosquito out, it will deliver substantial results for communities that we serve. So how is that different from, another Anopheles species? It's a great question, and part of the answer is in rural settings, in the African context, and Asia, et cetera, malaria is often spread by multiple Anopheles mosquitoes. And if we developed a solution for one of them, because it takes time and a lot of resources to build one of our solutions, if we could only knock out one of, say, 5 vectors and maybe 20% of the problem, it would be a huge amount of effort for very little or marginal impact. So what we do, and our team scrutinizes, we get requests to build mosquitoes and other pests almost every week from around the world, from governments, from companies, from farmers, all over the place. And we have to be convinced ourselves that if we were to develop this solution and deploy it effectively, that it would actually have to have a meaningful impact to move the dial. And for other, so Gambier mosquitoes, there are multiple complexes of that species. And it would be hard for us to rationalize to ourselves and to our stakeholders that we could have a meaningful impact. So short answer is we're going to take this mosquito out. It's a new threat, it's spreading, it's one species, and we're perfectly situated to know.
Yeah, let's talk numbers now.
Not a lot of mosquitoes have been released yet. A couple thousand, maybe tens of thousands. It's not many. Mosquitoes are small, and so when we start these pilots, but we will get up to the millions. Again, when we talk about real intervention pilots, which will be done over the next few years, we're talking about dosing in communities where this vector is present based on the density of the wild type mosquito in that area. So if the density is very high, and the mosquito in a community is really suffering from a heavy mosquito load, then we'll use higher dosing, more of our mosquitoes, in essence, to get out there and to capture a majority of the matings that will be had so that we can kill female generations after. And so that, we don't typically look at it in terms of the number of mosquitoes, but we're talking about releases over the next few years in multiple locations in Djibouti with dosing appropriate for meeting the challenge in that particular neighborhood. But overall, Oxitec has released well over 1 billion mosquitoes easily, probably being conservative. And the number keeps going up every day. So it's very safe. It's a normal thing for us. And of course, we're mindful with communities. They've asked us to be there, but we've spent 2 years, maybe 3 years, working in the communities with civil society, with government, hand in hand, to prepare these communities to be part of this effort, which is really a magical part of how we how we work. It's a very collaborative process driven by local leaders, and we're at their service.
Interested, the capacity for large-scale production and the economy of scale. So what can you say about this?
It's another good question. We think a lot about this. A good part of our team works in the labs building strains. We have a very large team that thinks about everything after that mosquito is completed. And as I mentioned, we think about product systems. So how do you actually build a system where you can manufacture it, put it into a vessel, ship that vessel, and deploy it in the field so that it works effectively? That's a complex issue. In addition to that is your question, this question, and that is how quickly can we build factories and how efficient are those factories? How many people can we ultimately serve? And that work is actually underway now. And understanding where we would place production capacity is a very important question. We always believe in large, efficient, centralized manufacturing facilities for any of our pests because the more efficient and the larger economies of scale you have, the lower the cost that we can pass on to communities in need. So for stephensi, if we think down the road a few years, as we're finishing that product system, piloted in the field, we are now in dialogue with a range of national malaria control programs and MCPs in additional countries that are picking up or detecting stephensi. So if you just take the East African context, we are building very close relationships with Kenya, with Tanzania, with Uganda, with Ethiopia. And at a point, we will get comfortable with where a production facility or more than one production facility would be. But this is a regional issue. And I think it is not lost on these African neighbors of Djibouti or in the region that a holistic approach needs to be taken because mosquitoes don't respect borders. A Ugandan Anopheles stephensi doesn't care where it was born. And so treating this from a regional perspective, I think, is going to be very important. And it's a very interesting set of questions to ask ourselves and our partners. Anyway, I love that topic. And I spend a lot of time in the region. I spend a lot of time with leaders in Africa. And again, the great part of the story here is that while the problem is big and spreading, there is a growing orchestrated kind of response. And that just really makes us excited because it means our technology will have a good chance of getting out there in a comprehensive and regional basis to solve this problem.
Let's look at timing. In the malaria space, the excitement continues to be around the malaria vaccine. And so what is your concern that malaria vaccines are taking the shine of this route?
I am very eager for vaccines to be effective. So I'm not worried about how it makes our product look. I'm worried about saving lives. And if we're going to end malaria in our lifetime, we need vaccines, we need vector control tools, we need rapid diagnostics, we need new drugs, new medicine, we need new ways of thinking about how to solve this. So I celebrate the recent advancements in vaccines, just as I celebrate other advances in this space. Having had malaria multiple times, but more importantly, having spent a good part of my career working in partnership with Africans in Africa on these tough topics, there's nothing more that I want than the most effective solutions for this disease. I am asked that question a lot, because if a malaria vaccine is out, does it mean that we don't need our mosquitoes? I mean, that would be a wonderful world. Oxitec has lots of technologies. We're busy around the world combating all sorts of threats and challenges. But I think the reality is, and I think I'm not alone in the public health community, the reality is that there is no silver bullet vaccine yet. And it's probably going to be some time before we look at the malaria vaccine ecosystem in the same way that the polio or the tuberculosis vaccine campaigns were carried out effectively. So I think that the international community is generally aligned that we need a new generation of vector control tools, of which ours is one. We need a new generation of vaccines, especially for wider spectrum distribution, lower dosing, and in terms of fewer doses needed, and at lower costs, and the other things I mentioned. We need all of it, but I'm not competitive with other products. I'm competitive against malaria.
Nicely said. And what about the response, especially the local feedbacks in areas where you've done some release so far? From the frontline perspective, what can you share?
Yeah. The topic of public engagement is really important, very, very important to us. And we have what we call, roughly a trust equation. And it stems from the reality that when you bring to a community anywhere in the world, from Soroti in northern Uganda to the Florida Keys to a Sao Paulo suburb, all communities deserve respect and all communities deserve a relationship that is built on trust. So when new technologies come to town, ours or any other new technology, we've seen in the successful cases, real care being taken to empower communities, to educate communities, and to incorporate communities into the introduction of these technologies. So our trust equation is built on being transparent. Oxitec is very transparent. We work very hard to establish a public scientific record that is peer reviewed. We are only in locations where we have been invited. Oxitec does not go into any community where it is not invited and hosted by local government or local communities. We spend a lot of time on the ground with people, door to door, in churches, at the park, at the farmer's market, in the fields where people are. We meet them where they are, physically and conceptually. And again, we spend a lot of time just being with them, talking and educating about the technology, but really listening to their concerns, listening to questions they have very carefully, listening to the challenge they have that we're trying to solve. I could go on, but for us, there's a methodical process we use to build trust. If we can't build trust, there's no way we're going to be able to serve these communities. And our entire reason for being as an organization, as a team, is to serve. And so we spend a lot of time. I personally spend a lot of time on the front lines. And I think that hopefully, symbolizes for those that watch Oxitec just how serious we take it.
Let's talk about measuring success. And I think you can't, probably you are, put a GPS tracker on each mosquito that is released. Or are you doing that?
Well,
Okay. So let's talk about the metrics and indicators of success, especially in these different phases of mosquito release. And if you can also talk about the cost benefit compared to other approaches. Does it make economic sense? Is it cheaper? Is it more expensive? Or is it the same? So yeah, metrics of success, indicators for the next stage of the release, and the cost benefits ratio in times.
Good. Two very good and interrelated questions. In terms of metrics of success, we have a number of metrics of success. So I'll go through a few of them. The easiest one to understand and the manifestation of the purpose of these technologies is to suppress mosquito populations. So metric number one, can we suppress to a significant degree a local disease spreading mosquito population? That's an easy one. Can we deploy it at scale? Can we develop it into product form factors that can be shipped hundreds or thousands of miles? Can we generate form factors or boxes or systems that can release these mosquitoes that are easy to use, that are safe for anybody to use? That's a major measure of success. From a manufacturing standpoint, there's a whole bunch of KPIs and measurements that we take, but from a technical and from a scientific standpoint, can a particular mosquito be manufactured with excellence, consistently, and at a low cost at scale? And there are a number of metrics that we pursue or test and then achieve to answer that question. And if the answer is we can achieve all of these manufacturing requirements for living organisms, for mosquitoes, which still blows my mind that we're manufacturing mosquitoes and releasing them for good. If we can't do that, then there's no product. And so we have a very large amount of effort that goes into it. There's other things in the field. Can we demonstrate to regulators and communities that our mosquitoes disappear from the environment? That's a big one for us because that's how our technology is designed. If you release Oxitec mosquitoes, there will be no permanent impact on the environment. Is the mosquito itself safe for frogs, bats, bees, fish, animals, and humans when released in proximity? We make sure that the answer, of course, is always yes. And I could go on, but let's talk about cost benefit, because when you do all of that work to show that you have a product, that it's viable and it's ready to launch, will anybody buy it? Can they afford it? So, great, we have the world's best technology, but what if it is not affordable for communities most in need? So for stephensi, the mosquito we're talking about with you today, that is absolutely a major metric of success. And we have basically a target product profile that we're pursuing that has been developed in partnership with communities in Africa, with experts globally, so that when we envision a deployment or an intervention, what does the intervention look like? How big does it need to be? How many square miles is it going to be? How often do we have to release mosquitoes? All of that goes into formulating what the cost is going to be. And whatever the cost is, X per mosquito, per person, per kilometer, we have to place that in the context of budgetary constraints and in essence, the cost basis that is used for other technologies. But when I'm asked about pricing and cost benefit, I think it's a difficult question to answer when anything else on the market right now is not working. So in a way, if you're paying $1 for an ounce of chemical pesticide, but it only works 20% of the time, or if you need to spend $2 or $3 on a solution that works 96 or 100% of the time, well, which one is more cost effective? One might be cheaper, but it's not working and people are dying. One might be more expensive, but it is highly effective and can save lives. There's no good answer to that because governments ultimately have to appropriate funds. They have to spend money. Donor organizations, if involved, have to make choices with limited resources. So we drive our cost down to the lowest possible unit. But because we're innovators with new products that have never been out there, it's hard to compare us to a bed net or a chemical or a trap or a drug or a vaccine because it's very novel. So that's a broad answer and maybe not so directly answered, but those are the things that go into us thinking through cost effectiveness.
Then, okay, before I drop that question on cost effectiveness, what are the insights you are gaining from the government, probably in Djibouti in the short term, but in places where you've already done this at scale? I think you mentioned Brazil and your interactions with the with those in the private sector, those that are already paying for your service. What insights are they giving you regarding the cost benefit?
No, it's great. I could talk about this all day, Paul. So thank you for spending time with me. So African governments on the stephensi topic, and this is broadly applicable to other mosquitoes we develop and other countries, other areas. They're desperate for solutions. They are desperate for solutions. When you have a problem, and you know what the source of the problem is, but you do not have a solution for wiping the source out, it's very frustrating. And I think professionals in public health professionals in governments in the Horn of Africa, East Africa, and now marching westward are all clamoring for new interventions. Governments know that funding for malaria globally is not going up. It's flatlined or it's going down. And so resources for these solutions are at a premium. And I think what we're seeing is governments start to project out and think through, by the time Oxitec is done with its mosquito, we're going to need to have funding streams or funding pools available to use and benefit from that technology. And that's why we're spending a lot of time out in capitals sensitizing governments as to what we're doing, what the solution it may look like when it's finally ready for scale, when it will be ready for scale. And there will be heavy work over the next few years to, in essence, prepare the community in the regions we serve for the use of this technology. So I don't have all the answers, actually, because we haven't completed our product system. We don't really have a unit cost yet. But in the absence of tools to effectively control this problem, with the acknowledgement that new solutions are needed within governments, I am highly confident that we will build partnerships that will enable this technology to be deployed everywhere that wants it. So, and a lot of that you mentioned is predicated on our experience working in other places and with other pests, other disease burdens. In Brazil, we're seeing that governments are eager for new solutions. They will buy those new solutions. They will deploy those new solutions and continue to do it. I suspect the same is going to be the case around the world for Anopheles stephensi.
Yes, I think you've gone to what I also want to talk about next, which is putting this approach in the context of global malaria control. We are still not aggressively seeing organizations like the WHO actively promoting this. There seems to be a line of perception on how malaria control works and how malaria elimination program is going to look like. Are you concerned that this is probably coming too late to the party? Or do you still think an epiphany moment can happen that will bring attention to this approach?
Yeah, it's a good couple of questions. We're not too late to the party. I'm sorry we don't have a technology today that we can deploy, but actually us moving into the malaria landscape is, it can't be too soon. It's needed right now. And we're just one group. There are a range of other technologies that are going to make up this, what I might call, next generation of the fight against malaria. What we're seeing is the first few decades of a concerted global effort to combat malaria worked really well. It saved many, many, many lives. And now we're seeing that plateau and slide backwards. So we're rushing in, the community, the international public health community is rushing in with a range of new weapons to fight malaria. And we're one of them. And I think for Stephen's eye, at least, we're going to be a very important one. And, to your point about resources dwindling, we have, I have two malaria experts right outside my conference room who will spend the afternoon with me. We have a global responsibility to advocate for resources to sustain the fight in malaria. And when I travel to meet donors, donor agencies, donor governments, WHO, foundations, philanthropies, everyone is really, really concerned about the lack or the diminishing resources. But I am actually hopeful because there is a general alignment that the failure to fund malaria control programs will prevent overall, globally, our shared goals of reducing mortality and in the developing world context, but also just globally. And in part because malaria is spreading. It's moving into new areas, or it's repopulating into areas where we had successfully removed it. And I think, so there's a great concerted effort to improve the resource base. It's going to take hard work. And, I think to the point of us developing our technology, we can turn into an exciting story for governments. We can turn into an exciting story. So I think for us, we're part of an exciting new movement. And I think we get a lot of attention because Oxitec technology is really powerful. It's really cool. But anyway, I think the problem is growing, but the chorus of voices is growing. And I'm very hopeful that we'll be able to turn funding around.
Public perception on genetically modified products. So how is that changing? Because for some countries and for some governments, that is a very, very tricky and delicate, we don't want to touch approach. So what is the level of acceptance regarding this approach?
No, it is a very serious topic. We do not take public acceptance for granted. Now, there are still places, there are governments and there are communities that do not favor genetic modification or the biological engineering of any type, GMO or CRISPR or any of the sort. But the good news is, overall, globally, I am seeing a real big shift in attitudes towards biology in a positive direction. And part of that is because it's becoming normalized. GMO technologies have been around for many, many, many years now. GMOs play a role in most all of our lives globally right now. And on the flip side, more biological engineering is going to be required if we're going to feed a growing human population efficiently without destroying our planet. We have to develop new medicines to combat these spreading disease threats. That will take biological engineering. For mosquitoes, our Oxitec has arguably the most successful suppression tool thanks to biological engineering. And the list goes on. And I think communities, governments are realizing that. So even if they had a very strong dogma against, quote, GMOs, we're seeing that thaw. We're seeing that not everywhere. There are still holdouts, but we're seeing governments start to recognize that if they do not adopt biological technologies, they will be left behind, or their populations will suffer as a result. Now, I think it's becoming less and less of an issue for us, but we do not take it for granted. We spend, as I mentioned earlier, a lot of time engaging, a lot of time in the public domain, communicating our science and sharing the stories of governments that have used our technology for good.
One last question before I ask for your last remarks. So what is a long-term vision for you as a person, and also for this line of tools in responding to a major public health problem?
Yeah, I think what's in store. So Oxitec is really just getting started, and that's why it's so exciting. It's this group of people I get to work with every day is comprised of some of the best humans that I've ever worked with. And when you bring together a wonderful team with a culture of trust and integrity, with resources and partners globally, our imaginations can take us to many, many places that Oxitec will be heading. So for us, practically, we are growing. We are adding new technologies routinely. And I think most exciting for me is the fact that we have built trust with a range of stakeholders and partners that are helping us do our best work. And I would give a major shout out to the likes of the Gates Foundation, the Wellcome Trust, a range of governments with whom we have deep and trusting relationships. They're helping us basically leverage our technology platform in a way that is really meaningful. So this Stephen's Eye program is in Djibouti it's kind of a culmination of many years of building trust with all of these stakeholders. And we do that every day with all of our partners in all the countries we work. So I'm just thrilled. So the future of Oxitec is bright. And frankly, we're doing some just world-saving kind of work, which is inspiring. And for the technology and for the community in general, to your broader question, I think, like I said earlier, I'm very hopeful about the fight against malaria. I'm very hopeful. I am not suggesting there are not major challenges and obstacles, but when you have a group like this, and there are other organizations in the world doing some amazing work too, you can't help but be hopeful. When I show up at work every day, I'm just inspired by our mission, by our partners, and by our people. Those are all ingredients for success when you want to take on a global challenge like malaria.
Well, thank you so much. Great. I think we have to wrap it up right now. Thank you very much for speaking to me. It was really a nice conversation.
Yeah, Paul, I love the questions. Again, thanks for spending time with me, and stay in touch. We'll absolutely provide any follow-up you need.